Good day, everyone. This is Mr. Tosin, your favorite chemistry tutor. You're welcome to chemistry class. Today, we shall be looking at gas laws, where we'll be talking specifically about Boyle's law. In the previous classes, you would remember that we talked about the kinetic theory of gases, discussing the behavior of gaseous particles. Alright, we talked about how gaseous particles collide with one another and with the walls of the container, thereby mounting pressure on the walls of the container and themselves. We also discussed the relationship between temperature and the average kinetic energy of the gas. So what are the objectives of this class? By the end of this class, we should be able to state 1. Boyle's law. We should also be able to write the mathematical expression, that's number 2. And then number 3, we should be able to draw the graphical expression of Boyle's law. And number 4, we should be able to explain how kinetic theory explains the Boyle's law. So Boyle's law states that the volume of a given mass of the gas, is inversely proportional to its pressure, provided temperature is kept constant. So that is what Boyle's law says. So what is the mathematical expression? Now, just from the law, the volume of a given mass of a gas is inversely proportional to its pressure, provided temperature is constant. Alright, so we can now say V is equal to K over P, where the K is the constant we're talking about. Cross multiply, you're going to have Vp equals K. V1, P1 equals V2, P2. And that is the mathematical expression for Boyle's law. These are the mathematical expressions for Boyle's law. Now, let's take the graph. Volume is centimeter cube. Okay, pressure, ATM. Alright, you will see that this is what we are going to have. As the volume is decreasing, the pressure is increasing. As the volume is decreasing, the pressure is increasing. Alternatively, we may have a graph that also looks like this: V centimeter cube, okay, and then 1 over P. We have the unit as per ATM, okay. The unit as per ATM, okay, and then we have it directly proportional sign. So telling us that volume is directly proportional to 1 over P. Okay, volume is directly proportional to 1 over P. That's why we have the graph going straight like that. So having known that, we should also understand this. I think this will buttress what we're talking about much better. So as we go from left to right, you see that V keeps increasing while P decreases. How kinetic theory explains Boyle's law? You can see these two containers of equal sizes. The first container 1, you can see that the piston is carrying certain quantity of load, and then container 2 has no load. Because this is carrying certain quantity of load, the volume is smaller, while the volume here is bigger. So, for 1, the volume is smaller, the intermolecular distance between the gaseous particle is lesser or is decreased, while the frequency of collision will increase because the intermolecular distance has been reduced. But here, the intermolecular distance is widening because the load is removed, and the frequency of collision reduces. So that is exactly how kinetic theory explains Boyle's law. Now, evaluation. 1 states Boyle's law. So you can answer this so easily. Thank you. Bye.